Okay, what I want to do right now is I have a question regarding of course, about malloc versus other option when we want to create a memory. So if you take a look at my break.c, break.c, okay, smaller. And in my break.c, you will see somewhere which I did malloc, which f name is equal to malloc. Okay, so why? Of course, this is a usage of the how to allocate the name. Strictly speaking, in this case, I'm not sure that malloc is necessary for me to create the space, but I want to leverage this opportunity to answer a question about the difference or need for dynamic memory allocation versus static memory allocation. Okay, so just give you an idea. So what do I mean by dynamic memory allocation? Dynamic memory allocation is either when you use the command malloc, or we haven't tell you about this, but there is a C++ version of malloc called new. And if you use, I would say this is a C++, which I haven't started talk about this. So whenever you want to use these two commands, then this is a typical scenario. We're doing dynamic memory allocation. And any other thing is static. Otherwise, it's static. Okay, first, I try to leverage about what's the difference between the two. Number one, that this has to do with the regions, different regions of memory that we want to use for certain variable. Okay, so there are in our computer system, especially this is controlled by operating system that has two different regions of memory. One of the region is what we call stack, and the other region is what we call heap. So, so what is a stack? Stack is that when you got the function call, you have a function one, call function two, and then your memory usage is basically stack one over the other. So function one is at the bottom, and then function two will be on top of that. And then function three, if you make another call, you actually go to have another stack. When the one of the function return, you kind of pop one of the stack. So this is called stack. There's a one region of memory, it's called stack. So essentially, if you don't declare dynamic memory allocation, everything will be on the stack. Let me show you this example. For example, integer ij here, those are on the stack. So those are the static memory allocation, okay? And then the other region of memory is called heap. Heap essentially is a different region of the memory that's not stack, not on the stack. Okay, so it's in a totally different region. Later, when you take ECS150, you will learn the detail about how the stack and heap, they're allocated. So, but for now, you just need to know if you do malloc or new, your data object will be on the heap, not on the stack. Okay, so that's, I should say, stack is for dynamic. Sorry, stack is for static. And heap is for dynamic. Okay, so that's from the memory or operating system view, the difference between dynamic memory allocation versus static memory allocation. So now this is the most important. I'm going to talk about is that under what situation you should use what? Meaning that when do we need to use dynamic memory allocation? I will just write it down. When do we need to use dynamic memory allocation? Okay, so this question I'm going to answer or provide answer. We need to use dynamic memory allocation if we like to access the variable or object after the function return. Okay, so why is this? So, I mean, let me give you an example. Let's go to, let me use a different one. Okay, over here I have, no, I don't want to use this one. Let me do CPP03. So we talk about record dot CPP. So inside record.cpp, we have a function called dump to JSON. This is a function, and inside this function, it will call another function is a GPS dump to JSON. So let's go to GPS.cpp. Yeah, here, GPS.cpp here. So this is a function, and at the end of function, it will just return the result. Okay, it will return the result. So the thing is that what I'm saying is that if we want to, sorry, this is the other one. I said if we need to access the variable after the function return, then we need to use dynamic memory allocation. Okay, in this case, let's go back to the previous one. In this case, if I define an integer x, and this integer x, because it's a static allocate, it is on the stack. So which means that this x will no longer be accessible when this function return, means this x is gone. So in other words, if you want to access the x, the variable x or its content after the function return, then the content of the x must be dynamically allocated. Okay, so let me actually give you an example. If I have a pointer called integer star xptr, okay? And then I will say x ptr is equal to mx, meaning that I'm actually provide a later possible access to the variable x using this pointer over here. So, however, because the integer x is static allocated, and once it's returned, once this is GPSDD dump to JSON return, this X is already being reused. The memory has been clear because it was on the stack, it has returned, so it got popped. And therefore, even you provide the pointer, it's basically not doing you any good because when you try to dereference, xptr is going to give you some value that's actually used by others. So in this case, if I think that I'm going to use x, I better do this. I should do this. In this case, I should do integer star malloc size of int. By doing this, you see that I the value of xptr is actually on heap. In this case, when you allocate the memory, the whatever dereference of xptr will never be erased. Okay. Does that sound clear, or you have some questions, Jonathan? Okay, I'm going to pause first. Okay, the other thing which I should mention, by the way, where is this code? This is operator overloading, right?
It's in, shoot.
That's okay, it's okay. I want to find out where is, let me see, graph person /n star.cpp. Okay, so this is in person.cpp. Let me do a person.cpp. Okay, the other way, which we want to make sure that you can preserve the value for the caller, is using call by reference. So for example, over here, if I have a function, let's pretend this is not operator overloading. So essentially, when I pass a function, pass a variable, which is a person in this case. So this particular part is really the reference means pointer, means address, even though C and C++, they have a different way to represent this syntactically. But this a person is being passed in from the function who call this particular function operator equal. So inside this function, if I actually make a change, say a person dot whatever is equal to 5. For example, if I make a change, this is basically just a code, I made it up. So when I did this, when I return from this function, that this change will be preserved as well. Because this function, by the way it defined, I don't know where the memory location is a person. So there are two cases. One is a person was being allocated dynamically. That's possible, but it could have been allocated statically, but by the function who called this function. So it's actually a static allocate memory in the calling stack, one stack element below. So that's why when this function is returned, the value is still preserved. So whenever you saw person n, this really represents an address from the C perspective. It's just passing an address. So when it's not being allocated within the scope of this particular function. Okay, does that help you understand a little bit?
And for the dot operator, it's acting on the pointer. Is it?
The dot operator is usually operate on the dot operator is usually operate on object or object reference. So this is a bit confusing. Okay, I have to say, let me do it this way. If a person is defined as person and a person, or it was defined person, a person, okay? You see that both of them are a person, but one is a reference, one is a regular. In this case, you should use dot operation. So this two, for both of this, you should use this one. But if you do this, if you do person star a person, so means that now this is a C style pointer. Then over here, you should say a person pointing to the whatever. Okay, so you see that this is two different style. If it's M or nothing, this, even though this is a C pointer, but it's a C++ syntax. So whenever it's a person, you still use the dot operator. Okay, for this two. But unless you define it this way, then this has become like a pointer. Okay, it's confusing, but I mean, whoever did this is just, yeah. I'm not going to criticize the contributor of earlier C++ language. Even though I really want to throw my coffee. Okay, all right.
Right.
Anyway, okay, is that good?
I think I
Okay,
got it.
okay, good. Oh, you're welcome.